Inequalities can be a greater than, a less than, or an equal to, and we're going to look at where the boundary point is, how it's shaded, and what direction it's facing. So here in problem A, I see that the boundary point is 1. Since the circle is colored in, I know it can be equal to 1, and then the arrow is darker pointing this direction, meaning x numbers that are going to be larger than 1. So the way we write that is we say x has to be greater than or equal to 1. If I go down to problem C, the circle is again colored in, so it's going to have an equal to, and the shading is going down the other direction for numbers that are less than 3. So we'd say that x has to be less than or equal to 3. If the circle is not colored in, that is a situation when we will not put the equal to line. So we would just say here that the x's have to be less than 1, but the number is not 1. Any number that's less than 1 would be true. The last one, D, is what we call a compound inequality. It has both a starting and stopping point. So we're going to take our x and put it in between. -4 is the smallest, and 2 is the greatest. And then we check, since 2 is a colored in circle, we would put the equal to line for the 2. Similar to how we've written domain and range in the past. So now we have to actually solve our own. Show all solutions to x minus 5 is greater than 3 as an inequality and on a number line. So step 1 is to solve for the boundary point. Treat it like it's an equal sign. 2x minus 5 is equal to 3. So we'll have to add 5, 2x equals 8, then divide by 2, we get x equals 4. That's the boundary point, that's not our final answer. If we go to a number line, 0, we look back at the original symbol, it did not have the equal to, so we know that our boundary point is not exactly equal to, so we'll leave an open circle at 4. And then we have to decide, do I shade towards the left, the numbers are less, or towards the right, the numbers that are greater? And the way that we're going to pick that is you're going to test any other value besides 4 and see if it's true. So for example, I might pick the number 1 as my test point. So if I go back to my original inequality and plug in a 1 for x, is that less than 3? So 2 times 1, or greater than 3. 2 times 1 is 2, minus 5 is -3. Is that greater than 3? -3 is greater than 3. No, that is false. So that tells us that 1 is the wrong direction to shade, and we should instead shade the other direction, going this way. And we could check by plugging in a number that's greater than 4. Try plugging in 5, 6, or 7 as the x, and it should work out. So if we put a 5 in here instead, 2 times 5 will be 10, minus 5 is 5, is greater than 3. That's correct. So now that we see our shading, we see that we want numbers that are greater than 4, so we write our final answer. X has to be greater than 4.